Okay, so it is time to do some derivatives here. Okay, so looking at what I have written on the top here is this f of x function 2x squared minus 4. And what we've previously learned is that the derivative of this function, f prime of x, we can find that using the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, if we went through all of this algebra and, worked it all out, which we're not going to do that on this video, we would get 4x. Okay, that would be our answer. So if you want to give it a try and see if that's what you get for practice, go for it. Okay, and really, this particular function is really not that difficult to find the limit and to do those algebraic calculations. But as we get into more complicated functions like, polynomials that have a lot of terms, and or maybe logarithmic functions, functions with, cube roots and fifth roots and that kind of radical type functions, what we find is doing this limit process is actually very, very time consuming. Okay. So what has happened in calculus is they've come up with these little shortcuts for finding derivatives. And so that is sort of like we can use these little shortcuts to just bypass doing all of that algebra. Now, sometimes there's still some algebra involved to do this, but it's way, way, way quicker than what you would be doing if you went through the whole limit algebraic calculation. Anyway, eventually we'll probably loop back and kind of talk about all of that a little bit more, but I just wanted to kind of explain that to you. What we're doing right now are these little shortcuts, okay? So you're going to learn each of these shortcuts, and then you can use these to get that derivative much quicker. All right, so the first one that you want to understand is our constant, okay? So a constant just means you have f of x equals c, where c is a constant. Constant means just like a number, okay? So like I said, there's no variable with it, okay, if that kind of helps you to understand. So let me give you some examples here. If my function f of x is just equal to 5, okay, 5 is a constant, all right, and the derivative of that, f prime of x, is 0. Okay, so once we recognize that we have this constant function, the derivative of that constant function is always 0. When you think about, like a y equals 5, like if you have, like this one is f of x equals 5, that's the same as y equals 5. That's just like a horizontal line going across at 5, right? So there's no rise to that. So the top part of the slope is 0, and then you do have some number on the bottom, but that would just simplify to 0. Okay, so that's why the derivative is 0 for a constant function, because it is a horizontal line. All right, so let's just do a few more here, just so you can kind of see what I'm talking about. If I have the function y equals 12, okay, and it's just not written in function notation, but here we would say y prime is 0, okay? If I know that m of t equals negative 16.4, that's a constant function, and m prime of t would equal 0. So these are pretty easy. You just always get 0, okay? So let's keep moving along here. The next one is the power rule, okay? And what you can see here is we have f of x equals x to the n, where n is the power, so it's some exponent, like it could be a 2 or a 3, okay? And then our derivative is always calculated by doing n times x to the n minus 1. Let me show you what that means, okay? So let's say my f of x function, go back to blue here. My f of x function is x to the third, or x cubed, okay? My n here is 3, okay? So what I need to do to find the derivative is I need to bring the n down to the front, so bring the 3 down to the front, and then it'll be x, and then it's going to be 3 minus 1 as the exponent, which is just a 2, right? So it's f prime of x will equal 3x squared. And that is the derivative, okay? Now, once again, if we did that whole limit, as h approaches 0 of this f of x function, okay? Sorry, shouldn't have said that. F of x plus h minus f of x over h, okay? We would get 3x squared when we did that whole thing, okay? So like helping you to understand, this is a shortcut to get to the same thing we would have gotten if we did that whole limit calculation, okay? So let's do a couple more here. Let's say my function is g of y equals y to the 7th. All right, my n here is 7, so g prime of y will be 7y to the 6th. Okay, all right, if I have k of x equals x to the negative 3, now this is a negative exponent. Students don't like negatives that much, but it works the same way. K prime of x, bring the n value down to the front, which is negative 3, x to the, and you're subtracting 1, so you're doing negative 3 minus 1, which is negative 4. Okay, so just be careful with those negative numbers because students tend to mess up on those. All right, let's get a fraction in there. So let's say m of t equals t to the 1/2. Okay, so really what happened here as a review, we could have just started with the square root of t, all right? Because we know that the square root of t is the same as t to the 1/2. We've talked about that before, okay? So what's happening here is my n is 1/2. So I'm going to be bringing that down to the front. So m prime of t equals 1/2 t, and then I need to subtract 1 from the 1/2, okay? So let me show you that here. So it's 1/2 minus 1. Now when you add or subtract fractions, we know we need a common denominator, and that will be a 2. So this will be a 2 over 2. Okay, I'm representing that 1 as 2 over 2 with the common denominator of 2. And then 1 minus 2 is negative 1, and then that 2 just carries across. Okay, so that's what I'm going to have as my exponent up here, negative 1/2. Okay, you just have to be careful subtracting, right? Subtracting 1 when you have that fraction involved so that you'll get the correct answer. All right, so let's say that we have f of m equals m to the 2/3. Let's just do another fraction example here, okay? So f prime of m will be 2/3 m to the, okay? Pause the video, try to figure it out yourself, and then play the video, see if you got it correct. But we're going to take the 2/3 and we're going to subtract 1. So it's going to be 2/3 minus 3/3, okay? And that's going to be negative 1/3. So that's going to be my new exponent there. So that's my derivative. F prime of m equals 2/3 m to the negative 1/3. Okay, so you can see that you might have to work on your fractions just a bit to, to kind of get that at a comfortable level. Okay. All right. Now, sometimes what they're going to do is they're going to give us a situation where we have to do a rewrite. Okay. So let's talk about a few of those here. Okay. So let's say they give us the function f of x is 1 over x squared. Okay. And we're trying to find our derivative here. So the first thing we have to do here is rewrite this with that x to the top of the fraction. Okay, so I'm not doing the derivative yet. This is just f of x, and this is x to the negative 2. All right, so you may need to go back and review your negative exponents a little bit if you're looking at that going, what the heck? Okay, now my derivative will be f prime of x, all right, and it'll be negative 2x to the negative 3. Okay, so it's similar to the k of x function we did up there, right? So you're subtracting 1 from the negative, so it's going to be more negative, right? Negative 2 minus 1 is negative 3, okay? So those rewrites can give students a little bit of trouble, okay? So you may find that you have to practice that. Let me give you another example here. Let's say we have k of x equals the 4th root of x cubed. Okay, so what we've got to do in this situation here is we've got to rewrite the function to get it out of that root. Okay, so remember, we've done this before. We've had this happen when we keyed in our formulas into Excel. This is going to be x to the 3/4, right? X to the 3/4. So now when I do the derivative, k prime of x, it's going to be 3/4 x, and then it's going to be the negative 1/4 because I'm subtracting 1 from 3/4. So I'm doing 3/4 minus 4/4. Let me write that here. 3/4 minus 4/4 is negative 1/4. Okay, and that is that new exponent that we're using there. So there's a lot going on here, right? You've got, first of all, you've got your power rule that you're learning, right? You've got to make sure you understand the power rule. But then sometimes we're going to be dealing with negative numbers, right? And then sometimes we're going to have to do a rewrite to get the function ready to use the power rule, okay? So sometimes the rewrites can be the trickier part of the problem. So just be really, really careful on that. Make sure you're asking for help if you need it. Okay, let's keep trucking along here. So this is constant multiple. So this is when you have a number out front that's multiplying to the function. So that's what they're talking about. K is a constant multiple. So let me give you an example here. It's always easier when you can just see one. So like let's say we have f of x equals 5x squared. Okay, now our k value here is this 5. All right, it's that number's just being multiplied to that x squared. Okay, so what it tells us is that we're going to just keep that k there, and then it's going to multiply to the derivative of the g of x function. Okay, so what we're going to do here is we're going to just keep the 5. Okay, that's our constant multiple. That's just going to kind of carry through. And then I'm going to take the derivative of the x squared, okay, which I will be using the power rule that we just learned, right? So it's going to be 2x to the 1, all right? And then we would just simplify that right there to say 10x, okay? So the 5 is a constant multiple. It's just sort of going to come along for the ride, okay? So g of x is 1/4 x cubed, right? This is my k. This is my constant multiple here, 1/4. It's just going to come along for the ride. G prime of x is 1/4 times, now I'm going to take the derivative of the x cubed, which is going to be 3x squared using the power rule there. And then I'm just going to simplify this and say 3/4 x squared, because 1/4 times 3 is 3/4. And that is my derivative. Okay, let's do another one here. We got k of x is 6x to the negative 3. 6 is my constant multiple there. So k prime of x is going to be 6 times derivative of x to the negative 3, which is going to be negative 3x to the negative 4, because you're subtracting 1 from that negative 3. All right, and then that's going to be negative 18x to the negative 4th when I simplify that. Okay, now let's talk about some rewrites here. All right, so let's say they give me this, f of x equals 3 over x squared. Okay, now I need to get this into a form where I can apply my rules that I know. All right, so what I'm going to do here is I'm just going to take this function and rewrite it to 3. I'm going to leave the 3 where it's at, but I'm going to bring the x squared to the top, which will be x to the negative 2. Okay. Please don't put the 3 in the bottom. Sometimes students want to just switch the top and bottom, but the 3 should stay where it's at. You're just bringing the x up, and then you have to change the sign of that exponent when you bring it to the top of the fraction. Now, what we have is a constant multiple of 3, and then I'm going to take the derivative. Okay, the 3 is going to stay in there, and then I'm going to multiply it by the derivative of x to the negative 2. So that's going to be f prime of x equals 3 times negative 2x to the negative 3. And then when I simplify that, I would say negative 6x to the negative 3. All right, so these rewrites can be a bit tricky. Here, let me show you another one that tends to trick students sometimes. Is g of x equals 1 over 3x squared. Okay, now my rewrite in this case, all right, the x squared needs to come to the top, but the 3 needs to stay in the bottom. I can't just move the 3. I can move the x up because I can switch the exponent from positive 2 to negative 2 and bring that to the top. But I can't do that with the 3. The 3 has got to stay where it's at. So g of x will be, think about just moving just the x squared to the top. Okay, and so I'm gonna do it a little weird here first, and then I'll show you how to think about that. So the 3 would stay in the bottom, x to the negative 2 on the top. Then what you want to do is you want to think of this as 1/3 times x to the negative 2. Okay, now the 1/3 is going to be my constant multiple. All right, and so g prime of x will be 1/3 times, take the derivative of the x to the negative 2, which is going to be negative 2x to the negative 3. Okay, and then I'm going to just simplify that by multiplying the 1/3 and the negative 2. That'll be negative 2/3 x to the negative 3. Okay. All right, so let me give you one more. I'm just going to write it down here, and then I want you to try to do this yourself, and then pause the video, and then you can watch me what I do with it to see if you did it correct. So you got to do a rewrite, all right, and then you're going to try to figure out the derivative. Okay, so your rewrite, okay, is going to be 4x to the 3 halves. Okay, make sure you are keeping that 3 in the top and the 2 in the bottom to represent that square root of x cubed. A lot of times students will do that backwards and tell me 2/3 instead of 3 halves, so be careful. Then 4 is your constant multiple. Okay, so my derivative here, k prime of x, is 4 times, and this is going to be times the derivative of that x to the 3 halves. So it's going to be 3 halves x to the, all right, now you got to subtract 1 from the 3 halves. So I've got 3 halves minus 1. That's 3 halves minus 2 halves. That's going to be 1/2. Okay, so that is my exponent there. So I have 4 times 3 halves x to the 1/2, and then I would multiply the 4 and the 3 halves to simplify this a bit. All right, so 4 times 3 halves is going to be a 6. So 4 times 3 halves is really 12 over 2, which will be 6. Okay, and then that's x to the 1/2. Okay, so that would be my final answer for my derivative. Now, let me point out something really, really important that students do wrong all the time, okay? So please, 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 please pay attention because this makes it's a small thing, but it makes a big problem for you in the long. It's like a really bad habit. One thing students want to do right here is they want to write f prime of x right there in that step, okay? But you cannot do that because you only should write the f prime when you're actually finding that derivative. When you're doing a rewrite, you're not taking the derivative at that point. You're only just making the function look different as far as how you're writing the function. So you need to leave it as f of x right there. So do not put f prime of x until you're actually doing the derivative, okay? So you notice like here, I still just said g of x. I did not say g prime of x right there, okay? Here I said k of x. I did not say k prime of x, okay? But for some reason, a lot of students want to go ahead and say like k prime of x right there. And then what happens is they think they're done. They think they found the derivative because they wrote k prime of x, but you didn't actually find the derivative. That was just the rewrite of the function. So be careful with that, okay? All right, so let's keep trucking along here. So we've got sum and difference. Now, sum and difference is really just what we've already learned, but just extended into like more terms, okay? So let's do some examples and then I'll show you what I'm talking about. So let's say f of x is x squared plus 6, okay? So what we have here are two terms. We have x squared is a term and 6 is a term. So what the sum and difference rule tells us is to just take the derivative of each term, all right? And you just, if it's plus, then you keep the plus sign. If it's minus, then you keep the minus sign. So you're just going to look at each term kind of as a separate little derivative, and then you have the derivative of the whole thing, okay? So I'm going to write this out here. So f prime of x, I'm going to take the derivative of the x squared, which is 2x to the 1, and I'm going to take the derivative of the 6, that's a constant, that's going to be a 0, okay, and then I'm just going to clean that up a little bit, and that's just going to be 2x, okay? So you're just looking at each term and doing the derivative of each term. That's really all you're doing. So it's just a continuation of what we've already learned. So let's say g of x is 4x cubed plus 3x squared. Okay, now what you have here are two terms. Okay, so you're going to take the derivative of the 4x cubed, and then you're going to add that to the derivative of the 3x squared, just taking the derivative of each term. Now within each term here, you've got a constant multiple of 4 here and a constant multiple of 3 there. So we're going to be using the constant multiple with the power rule, right, for each of those. Okay, so you're just building all of these things together here. I can't get those to erase. I don't know why, so I'm just going to move on. All right, g prime of x. So constant multiples, remember they just sort of come along for the ride. So it'll be 4 times, use your power rule here, 3x squared, okay? Constant multiple of 3 comes along for the ride. Derivative of x squared is 2x, okay? So now we've got 12x squared when we simplify this plus 6x, all right? And that would be our derivative of g, okay? So you can see you're just kind of building things up here. So let's do one that has some rewrites to it. So let's say k of x, 4 on the cube root of x squared plus 4 over x squared minus 5. Okay, that's my k of x function. First thing I need to do is rewrite k of x to get it in a form that works for my derivative rules. So I'm going to have 4x to the 2/3, that's my rewrite on that cube root of x squared. and then this is going to be 4x to the negative 2. The 4 should stay in the top. You're just moving the x up. All right, and then it's just going to be minus 5. Okay, so it's k prime of x equals, all right, now 4, this is a constant multiple, okay? I have another constant multiple of 4 there, all right? So remember, those just come along for the ride. So it's 4 times, now I'm using my power rule here, so that's going to be 2/3 x to the negative 1/3. I'm subtracting 1 from the 2/3. All right, then plus 4 times negative 2 times x to the negative 3. And then this 5 down here, this is just a constant. So the derivative of constants is a 0. Hopefully that's showing up there. Okay, so let's clean this up a little bit. So k prime of x. All right, I'm going to multiply the 4 times 2/3, which is 8/3. X to the negative 1/3. And then I'm going to multiply the 4 and the negative 2, which is negative 8. X to the negative 3. And then we can just drop the 0. Okay, so that is my derivative of the function k. All right, so you can see it could be a bit tricky here, right? You might need to do some practice, right? Especially with the rewrites. And then kind of just get comfortable. Once again, notice here, I did not say k prime of x. I just said k of x because I was only rewriting the function. I was not doing any derivatives there. Okay, I will be pointing that out a lot, especially if you do that on your assignments or quizzes or whatnot, because I don't want you to start that bad habit because it kind of just creates a big mess for you as things get more complicated. All right, so we're going to try to nip that in the bud here pretty early on. All right, let's do one more in that section. This one's kind of tricky, so I want to do one of these with you, and then we'll move to the next section. So let's say my m of x function is 1/4, and then I have the square root of x cubed in the bottom. Okay, my rewrite here, okay, this is where students usually mess up. The first thing I'm going to do is think about that's 1/4 x to the 3/2. Okay, so I'm just changing the root to 3/2 exponent. Okay, now m of x, I need that variable to come to the top. Now I cannot move the 4. This is what students do all the time. They'll say 4x, and then they move that x to the 3/2 to the top, and they tell me negative 3/2. That is not correct, okay? Because you cannot move the 4. The 4 needs to stay in the bottom. So it's going to be x to the negative 3/2 on the top, but 4 on the bottom, like that, okay? Now, what you want to do now is just think of that as 1/4 times x to the negative 3/2. Okay, notice I have not done a derivative yet. Okay, all I have done here is just did the rewrite of the function. Okay, that's just all rewrites. So now if I take the derivative, okay, it's 1/4 times negative 3/2 x. I'm subtracting 1 from negative 3/2. Okay, so let me just write that out here. Negative 3/2 minus 1 is negative 3/2 minus 2/2, and that is negative 5/2. Okay, so that's going to be, sorry about that. Okay, negative 5/2 is my exponent there. Okay. Now, to finish this off, I'm just going to simplify that. I want to multiply the 1/4 times the negative 3/2, okay, and that's going to be negative 3/8, and then x to the negative 5/2, and we can stop right there. Okay, so anyways, hopefully seeing all these examples is helpful for you. The more you can do these problems, the easier they get, but they do take a little practice. All right, so let's talk about two more here. So our base e, these are easy. Students really like these a lot because if I have e to the x, then the derivative is e to the x. So it's the same, you get the same thing back when you take the derivative, okay? Now, so like, let me show you just a couple basic examples here. So like, let's say f of m is e to the m, okay? So because they don't have to use an x, right? They can use whatever variable they want. F prime of m would be e to the m. You just get the same thing back, okay? Let's say g of t is e to the t. G prime, oops, changed it to the highlighter by accident there. G prime of t would be e to the t, okay? Now, what they can do here is like, let's say k of x is 4e to the x. Now, what they've done is they've added in a constant multiple there, okay? So that constant multiple would just stay out front. So k prime of x would be 4 times the derivative of e to the x, which is just e to the x. So it would be 4e to the x. So sometimes the easy ones can also be tricky, right? Because you're like, was it really that easy or did I do the problem wrong? So you just have to be a little bit mindful of what you're doing. But the e to the x function, you just get the same thing right back, e to the x, when you take the derivative. All right, now my natural logarithm here, okay, it's telling me up here that if I have the natural log of x, the derivative of that is 1 over x, okay? So, so let's do a couple of examples here. So let's say I have g of w is the natural log of w. That's my function that's given. My derivative is g prime of w is 1 over w. All right, so I'm just going to take what's inside there and just drop it right in the bottom of that fraction. Okay, so this one's a little weird, I think, for students sometimes. S of t is the natural log of t. They don't have to put the parentheses there. They can if they want to. S prime of t is 1 over t. Okay, once again, like if they give you f of x is say 1/2 natural log of x, then this would be a constant multiple out front. So f prime of x would be 1/2 times the derivative of the natural log of x, which that's 1 over x. Okay, so then we would say it's 1 over 2x, like that, if we simplify that function, okay? All right, so that's it for this video, and we will continue this with putting things all together, and I'll show you a few more examples in the next video.